Hello, everyone. Welcome to SysGuide's YouTube channel. In this video, I will show you how to install Fedora Workstation 40 with Luks Full Disk Encryption and also with Snapshot and rollback support. I will install Fedora Workstation 40 using the command line interface rather than the default Anaconda GUI installer. This is because the Anaconda installer does not support encrypting the boot directory. Also, by using a command line interface, you can perform an advanced installation. Once the Fedora operating system is installed, I will install the Snapper and Grub-Btrfs packages. With the Snapper and Grub-Btrfs packages installed, you will be able to create, delete, compare, and revert differences between snapshots. So if you make a mistake while modifying the system configuration, installing packages, or updating, you won't have to worry about breaking the system. Simply restore the snapshot prior to the problematic change, and you'll be fine. For this guide, I will use a hard disk with a capacity of 128 gigabytes. This is how the disk partition looks. I will create a 600 megabyte EFI system partition and use the remaining disk space to create a partition for the Linux file system. Fedora also creates a swap-on-Z ran during boot, so no separate swap partition is required. I will not create a separate boot partition because I want the boot directory to be part of the system root. So when you undo changes between two snapshots or roll back a snapshot, the boot directory is also rolled back along with the system root. This eliminates kernel mismatch with a reverted system. Then on the Btrfs volume, I will create subvolumes for these directories. Some directories contain temporary files and caches. Others contain data that you do not want to lose if you roll back the system root. And some should be in read-write mode when booting into a read-only snapshot. So let's get started. Boot your system using the Fedora 40 Workstation Live Installer. In the Welcome to Fedora window, click the Not Now button to return to the GNOME desktop. Open GNOME terminal. Let me change the terminal's font size and color for better visibility. Open the Firefox web browser. Go to my website and click on this tutorial. I will copy and paste all of the commands from this web page into the terminal to avoid typos and save time typing them. I strongly recommend you also do the same. I will add a link to this tutorial in the description. Change to super user. Fedora installer does not include the gdisk package. So install it. Locate the disk on which you want to install Fedora. For me, it is dev-vda, which is 128 GIB in size. Yours will be different. In the disk _device variable, set the name of your disk device. I will set it to /dev/VDA. You should replace this with your own. Now create an EFI system partition. The EFI system partition will be partition number 1 with 600 MIB in size. Type code is EF00, which is EFI system partition. I will name the partition as ESP, but you can give it any name. And finally, the disk device, which in my case is /dev/VDA. Next, create a Linux file system partition on which Fedora will be installed. This will be partition number 2. I will use all of the remaining disk space to create this partition. Type code is 8300, which is a Linux file system partition. I will name this partition as Linux, but you can give it any name. Press enter. List the partitions you just created to ensure that everything is in order. Get the device name of your EFI system partition and set it to the ESP_PRTN variable. It is /dev/VDA1 for me. Next, get the device name of your Linux file system partition and set it to the Linux PRTN variable. This will be /dev/VDA2 for me. Now you need to initialize the /dev/VDA2 partition as a Lux device and set the initial passphrase. So copy this command and paste it into your terminal. I will set the type to Lux version 2. I will label it as Fedora_Lux. You can set it to anything you want. Grub currently only supports PBKDF2 algorithm. For PBKDF2, the minimum iteration count is 1,000, and the maximum is approximately 4 billion. The more powerful your CPU is, the higher the iteration count will be, and the higher the iteration count, the longer it takes to unlock the Lux in the Grub. So I have set the iteration count to 500,000. For this iteration count, it will take about 10 seconds to unlock Lux on my computer. Lowering the iterations reduces security. To get around it, use a more complex passphrase with higher entropy. The passphrase entropy should be at least 60 bits or higher. In the description, I'll include a link to the web page where you can generate strong passphrase. Now, press enter. Type yes in capital letters and enter your passphrase twice. open the Lux device and map it to the temporary name TMP Lux. I will map the Lux device to proper UUID later. For now, enter the Lux passphrase you just provided. Now you need to format the partitions with the appropriate file system. Format the EFI system partition with the FAT32 file system. I will name the volume as EFI. You can name it whatever you want. Next, format the Lux mapped device with the Btrfs file system. I will name the volume as Fedora. You may name it whatever you want. Now check your setup. This is how your setup should look. The UUIDs will be unique to your system. Now I'll get the UUIDs of the Lux partition and other file systems and store them in variables, because I will be using these UUIDs frequently. Get the UUID of the Lux formatted Linux partition and save it in a variable. Get the UUID of the ESP and save it in a variable. Finally, get the UUID of the Lux mapped device with Btrfs file system and save it in a variable. Confirm the UUIDs you saved are correct. Now, you must create subvolumes on the Btrfs file system. So mount/dev/mapper/tmplux to /mnt. I will set the compression to ZSTD with a compression level of 1, which is the default in Fedora. You will receive the SE Linux label warning. The restore context command will fix this. I will now create subvolumes. Copy all of the commands. Create one temporary file. And paste the command into it. Remove the hash symbol from all lines. Press Ctrl+V. Go down until the last symbol. Right arrow. And press X. If you're installing Fedora for the KDE desktop, make sure GDM is replaced with SDDM. Save the file and exit. Now source the file. List the subvolumes. It should look something like this. I'll create the remaining subvolumes once I've set up a user account. You must modify the permissions of certain directories. also change the attribute of the images directory. The C attribute on the directory causes new files created in that directory to have the no cow attribute set. This will avoid low input-output performance for virtual machine images with cow file system. Now that you've created and mounted all of the necessary directories and subvolumes, you now need to create a Fedora system in the /nnt directory. I'm going to install the base system package first, which defines the basic elements of a Fedora system. I will be installing in the /nnt directory, and the Fedora version will be 40. Next, bind mount the directories sys dev and proc into /nnt. Copy from for to done. Paste it into the terminal and hit enter. Next, install Fedora minimal. Copy the command. Paste it into the terminal. I've included the Fedora minimal package groups, kernel, Linux firmwares, language packs, Grub, and some other relevant packages. Press enter to install. Do not install a full desktop environment like GNOME or KDE in the chroot environment. During the installation process, the desktop environments will run several scriptlets. Vast majority of these scriptlets cannot be executed in a chroot environment. After you exit the chroot environment and boot into Fedora minimal, you can install your preferred desktop environment. Delete the existing symbolic link to the resolve configuration file and create a new one by copying the configuration file from the host to the etc directory so you can connect to the internet after rebooting. Set the time zone, locale, key map, hostname, and machine ID. I will set the locale to US English, key map to US, time zone to US Eastern. I will set the host name to Fedora. You can change it to anything you want. And finally, initialize the system's machine ID to a random ID to find out your locale, key map, and time zone. Run these commands. You also need to include a console font. This font is the default in Fedora for all European-based languages written in Latin Greek letters. You must also configure the system keyboard mapping for X11 and the virtual console. So first create xord confd directory. copy the command from cat to EOF, paste it into your terminal, and then press enter. I have set X keyboard layout to US. To determine your X11 layout, run this command. Change root into the MNT directory. You should enable the fastest mirrors to speed up package downloads. So copy the command from cat to EOF, paste it into your terminal, and press enter. Clear all previous caches and update the local DNF metadata cache. Now that you are in a CH root environment, reinstall the Polkit package to ensure that the Polkit scriptlets are properly regenerated. Now, proceed to create a user account. I will create a username using my name. You change the username to something more specific to you. I will also add the user to the wheel group. This grants the user super user privileges. The shell will be a bash shell. Set the password for the user. Now that the user account has been created, I will proceed to create the remaining subvolumes. Switch to the user account. Create user home directories. Since Firefox is pre-installed on the Fedora Workstation, I will create a subvolume for the .mozilla directory. However, you can create more subvolumes based on your needs. If you plan on installing Google Chrome, you should also create a subvolume for it. If you plan to install the Mozilla Thunderbird email client, create a subvolume for it also. If you use the GNU PG encryption and signing tool, you must create a subvolume to avoid losing your keys. Similarly, if you use the SSH remote login client, you must create a subvolume to prevent losing your keys. Check your subvolumes. It should display the new subvolumes you have created. I have only created the .mozilla subvolume in the user's home directory. If you have created any additional subvolumes, they will be displayed here. the newly created subvolume directories will be owned by root. So change the ownership of the newly created directories to your username. And restore the default SE Linux security contexts. Finally, log out and return to root. You must now create the fstab file so that the Fedora operating system can mount all of the necessary mounts at boot with no errors. Set the mount options for Btrfs subvolumes in the options variable. Get your subvolumes and store them in a subvolumes array. Print the elements in the array to see if all the subvolumes are properly added. Find the length of the longest element in the subvolumes array. For me, it's 24. The length of this element. Now print the system root mount in fstab file. Copy the command. Paste it into your terminal and hit enter. Next, print the EFI partition mount in fstab file. And finally, print the rest of the subvolume mounts in fstab file. Copy from for to done. Paste it into the terminal and press enter. Examine your fstab file. Here's how it should look. The UUID and username will be unique to your system. Mount all the subvolumes. List your subvolumes. And finally, check your setup. It should now look somewhat like this. Now you must create the grub configuration file. When Fedora is installed using the Anaconda GUI installer, the grub configuration file is automatically created. And since you are using the command line interface instead of the Anaconda installer, you must manually create this file. So copy the command from cat to EOF. Paste it into your terminal and hit enter. review the file. The UUID will be unique to your system. I have added the key that will enable crypto disk. When crypto disk is enabled, it will look for encrypted disks and generate the necessary commands to access them during boot. I have also added the key that will enable snapshot booting. With this feature enabled, you can boot directly into Snapper snapshots from Grub menu. Next, you must modify the grub.cfg file located in the EFI partition. This is how it looks right now. Copy the said command. Paste it and press enter. Review the file again, and it should now look like this. The UUID in the crypto mount line, in my case, is of the /dev/VDA2 partition with no dashes. Update the grub.cfg file. Check your grub configuration, and here's how it should look. Add the encrypted block device to the crypt tab file so that it is enabled when the system boots. You must now add Fedora to the boot entry. So first get the ESP partition number. For me, it is 1, which is /dev/VDA1. Copy this command and add Fedora to the boot entry. As you can see, Fedora has been added. Enable the Network Manager service. Also enable the Audit D service. Exit the chroot environment. Unmount /mnt. And turn off your system. Remove the Fedora Live installation media and start the system. You will be prompted for the passphrase twice. The first time is before loading Grub. Depending on your computer's CPU, it may take up to 15 seconds for the Grub to display the menu. So please be patient. Please keep in mind that the asterisk cursor will not appear as you type the passphrase. So you should assume you have entered your passphrase correctly and then press the enter key when finished. The second time the passphrase is requested is before mounting the root file system. Later in the video, I will show you how to enable the single passphrase prompt. Log into Fedora. The Fedora 40 minimal installation is now complete. You can now install the desktop environment of your choice. I will install GNOME 46, which comes with Fedora's official desktop edition, Fedora Workstation. Alternatively, you can use this command to install the KDE Plasma 6 desktop environment. Regardless of the desktop environment you have installed, you should enable boot animation, list the themes available for you. I will set the spinner theme as the default. Now reboot the system. You will now be logged into the Fedora Workstation 40 with the all-new GNOME 46 desktop interface. The Fedora Workstation 40 installation is now complete. Well, the grub requests a passphrase to decrypt the encrypted boot files. It does not pass this information on to initramfs. As a result, the root file system must be unlocked once more during the initramfs stage. This means you will have to enter the passphrase twice. I will show you two methods to automatically decrypt your disk without requiring a second passphrase. Choose the one that fits your requirements. The two methods are using a key file or using TPM2. Regardless of the method you use, you must first collect some data and store it in variables. This eliminates errors and makes copying and pasting simple. So first change to super user. Get the name of your disk device. For me, it is /dev/VDA. Now get the device name of the Linux file system partition that is Luks encrypted. Copy the command, paste it, and press enter. For me, it is /dev/VDA2. Next, the UUID of /dev/DDA2. Now, proceed to decrypt your Luks encrypted volume. Use this method if you want to decrypt your Luks encrypted volume using a key file. Secure boot does not have to be enabled for this. Create the directory crypt setup -keys.d in /etc. Create a key file with 4 KIB of random data. Ensure that only the root user has read access to the key file. Attach the newly created key to the encrypted device's available key slot. The algorithm should be PBKDF2. The iteration count must match the one you specified earlier, which in this case is 500,000. When prompted for a passphrase, enter the same Luks passphrase you provided earlier. Next, you need to include the key file in the init-ram fs image. So add the key to cryptodisk.conf file. Now we build the init-ram fs image. And finally, reboot. Enter your Luks passphrase and hit enter. As you can see, the second Luks passphrase is automatically decrypted using the key file. Use this method if you want to decrypt your Luks encrypted volume using the TPM on your computer. You must have secure boot enabled for this method to work. Before proceeding, let me quickly redeclare variables because I lost the values when I rebooted the system. Make sure secure boot is enabled. Also, make sure your computer supports TPM. Now enroll your encrypted volume. When prompted for a passphrase, enter the same Luks passphrase. Now confirm that the TPM has been added to the encrypted volume. As you can see, TPM2 has been added to slot 2. Add the TPM to device node path to the kernel parameter RD-looks options. Confirm the grub kernel parameter now includes TPM2 device node path. Update the crypt tab file. Include the TPM2 TSS module in the initram fs image. Update the grub.cfg file. And run Draka to rebuild the initram fs image. Finally, reboot. Enter your Luks passphrase and press enter. As you can see, the second Luks passphrase is automatically decrypted by the TPM. Snapper allows you to create, delete, compare, and revert differences between snapshots. So install Snapper. You must now create Snapper configuration files for the Btrfs volumes located at system root and home. You would normally use this command to accomplish this. But as you can see, it throws an error. It's the same for the home as well. And this is because you have already created the directories /.snapshots and /home/.snapshots. These directories were created automatically when you created snapshot subvolumes. And to resolve this issue, you should manually create Snapper configuration files. Fortunately, Snapper already includes a template configuration file. All you need to do is copy it and make a few changes. So first, create a Snapper configuration called root for the Btrfs volume at root. And then copy and paste this sed command, which will add your username and set the ACL. Check the configuration file. As you can see, the subvolume is root. Your username has been added to the allowed list, and ACL has been set for the user on the directory /.snapshots. Repeat the procedure for the Btrfs volume at home as well. Copy and paste the configuration file with a new name as home. Make the necessary changes to the configuration file. Check the configuration file. As you can see, the subvolume is home. Allowed user, and the ACL you should also update this file to include the Snapper configurations. Open the file. And as you can see, root and home have been included. Confirm that the Snapper configuration files were successfully created. You should also prevent update DD from indexing the snapshots directories. It is enabled by default, which can result in significant slowdown and memory consumption if you have a large number of snapshots. Finally, list the snapshots. Check the snapshots for system root. And also for the home directory. At this stage, you do not have any snapshots. We will create some later. In my other video where I tested Snapper, I demonstrated how to create and manage snapshots. Please review that video. I will include a link to that video in the description. Now that you've installed Snapper, you must now install Grub-Btrfs. While Snapper allows you to create snapshots, Grub-Btrfs allows you to boot from one of those snapshots. If you encounter a problem with your Fedora operating system, you can boot into one of the Snapper snapshots from the Grub menu and restored the system. Clone the Grub-Btrfs repository. Change to the Grub-Btrfs directory. The setup is pre-configured to work with Arch and Gentoo out of the box. To make Grub-Btrfs work with Fedora, you must make a few changes to the configuration file. Copy from sed to config, paste it into the terminal, and press enter. Install Grub-Btrfs. You will see the no snapshots found error. This is because you haven't yet created any snapshots. So don't worry, it'll work fine after you do. Update Grub. Enable Grub-Btrfs service. The Grub-Btrfs installation is now complete. You can now delete the clone Grub-Btrfs repository. Now that you have installed and configured everything you need to manage snapshots, it is time to create a subvolume snapshot of the main volume and make it the default system root. This allows you to roll back snapshots without having to specify the snapshot number when using the snapper tool. So first create a directory named 1 in the /.snapshots directory. Create an XML file called info.xml in the 1 directory. Copy from sudo to EOF. Paste it into your terminal and press enter. Make sure that the date is set properly and is in UTC format. Now create a read-write subvolume snapshot of the system root in the 1 directory. Get the ID of the new subvolume you have just created. For me, it is 272. Set the subvolume in the 1 directory with ID 272 as the default subvolume for the system root. Confirm that the subvolume is set as the default. And finally, reboot. As you can see here, there is still no snapshot menu in the Grub. When you take a snapshot with the snapper, it is automatically created. As you can see, the subvolume in the one directory is the default and currently active. Your system is now ready to take snapshots. This concludes the video. I highly recommend that you watch my other video on managing snapshots. In that video, I ran some snapper tests to ensure that everything was working properly and that there were no problems. Until next time, goodbye and take care.